Hello. I'm pretty sure by now you've heard about Windows Hello, the ability for you to use your face or your fingerprint to authenticate to Windows. We have seen a large amount of excitement from our users around it. And what I'm about to tell you today is that we have expanded Windows Hello support to Microsoft Edge. So now you can leverage the Windows Hello that you love within browser. Windows Hello was part of a two-factor authentication solution that was built into Windows 10 called Microsoft Passport. The idea of Microsoft Passport was to provide a roadmap for our users to come to a world where they don't have to type their password anymore, in a world where they're not subject to all these password compromises, and also at the same time have a much more convenient experience compared to password. I'm pretty sure each of you guys have remembered a day where you had to reset your password at the worst time possible because you have so many of them. So Microsoft Passport and Windows Hello was a solution to address that issue. In the previous versions of Windows, we supported Microsoft Passport and Windows Hello as part of the application authentication, protecting access to enterprise contents. And with the next version of Windows, we're also going to support it in Microsoft Edge. The best way for me to show you how great this experience is to actually demo it for you. So what we have done is to build a website for the sake of this demo. And I want to call it out, it's not something you can access from home, but allows you to see what great experiences you can build if you plug into the Microsoft Passport and Windows Hello on Edge. So here in this website, this is the sign-in option. And let's say I want to add my account on this new device such that I can start using it for my authentication. So let me go ahead and click on register an account. There you go. So now I have to sign in. Well, you know what? I still have my password, so I'm just going to type it here. And the account name that we have here is this account. And then here's my password. And again, here's what you see when I turn to register on this Microsoft Edge. This UI shows up that tries to authenticate my face. I'll show you why this is important in a minute. So let me go ahead and show my face. There you go, get authenticated. And I'm signed in. So now, once I added my account and Microsoft Edge remembers it, if I sign out, let's go through my experience. So my account now shows in this drop-down, the second one. And when I click on sign in, and if I show my face, I get immediately authenticated and I'm in. So by 2 simple clicks, I managed to get access to my account and I don't have to type in the password anymore. I want to call out a few things. The experience was obviously very cool, at least I think so. But it's not just the fact that it's so convenient, it's also that it's more secure. Because the actual authentication that happens there is using Microsoft Passport. It is using an enterprise-grade security, a two-factor authentication to get access to my content. The password is not used anymore, and that's a very important point that you need to keep in mind. And this is kind of the vision that we have set with Microsoft Passport within Microsoft. We wanted to kind of be part of the leading effort to deprecate passwords. And the way we thought about this is that the only way to succeed is to collaborate with the industry leaders and other browser vendors to come up with standards that works everywhere. That is the reason why Microsoft joined FIDO. FIDO is a consortium of companies and browser vendors and identity providers that their sole goal is to come up with new standards and devices that can kill passwords forever. And as part of that effort, a set of standards have come out about the browser APIs. And I'm happy to report that Microsoft Edge is the first implementation of such APIs. Obviously, being the first implementers also mean that these APIs are subject to change. These standards are not finalized, and right now the set of API specs have been moved from FIDO to W3C, which is another standard body that oversees the browser-specific specs. And as that standard body goes through this, the API signature will change. But what we want you to know is that this is a very good opportunity for you to start prototyping and playing with this experience, to get an insight of what's coming next. Being an experimental API, we have actually used the namespace MS to kind of clarify that these are experimental. But that being said, I think there's a lot of value in just trying to think about a world where there's no password and how you would design a user experience. And with Microsoft Edge, you have that opportunity. But again, the promise is not to build something that only works on one platform. The promise is to build something that works everywhere. And while this is what we build today, which is with Microsoft Edge, now we can support biometrics, including fingerprint and face. In future, as part of our FIDO engagement and promise, what we want to build is also expand that to other devices that you own, the devices that are being plugged into FIDO framework. So imagine next time you go to your cousin's place and you're on their PC and you want to log into your favorite website on their PC, you can use your phone or any form factor that complies with FIDO spec and then log on to that website. This is the kind of future we're trying to build here. Now again, the first step we took was to enable that with the biometrics verified on the PC. But the long-term goal is to expand this to outside just your PC. If you can use your phone to authenticate to a website on your cousin PC, that means you never had to type your password or any credential for that matter. And that's very important. And again, we want to stop using password all throughout. So anyhow, I hope the point is clear. Now, and perhaps I need a little bit of primer before I talk about these two APIs, but suffice to say that we only have two APIs, and that's all you need to work with this framework. Very simple. The best way to explain how this framework works is to understand how Microsoft Passport Authentication works. Microsoft Passport Authentication is basically based on an asymmetric cryptography, very similar to how a smart card works if you're familiar with it. If I want to explain this in very simple terms, think of it as the user client, basically your PC, creates a key pair. One is called a public key, and one is called a private key. And then the public key goes to the server. Perhaps the best way to make this simpler to understand, think of that public key like a lock, right? And you can give this lock to anybody. But because you have the key that opens the lock, you are the only one who can open the lock. And the promise is, if you can prove that you can open the lock that the server has, you have technically proven that you are the owner of the private key or that key, and so it's you. That's basically the idea. And with that kind of terminology in mind, we have two APIs that basically, one of them creates that key pair on the device, and the second one that basically that ceremony of proving that you can open the lock is done by the second API. So the make credential creates a public key and a private key on the device, and the get assertion is used to prove that the user has the private key associated with the public key, and the server knows the public key. So just to basically put into perspective, when I registered my account, if you remember from the demo, and you saw that that prompt that show up that uses my face for authentication, that was the time a key pair was being created on my device. That was the time that make credential was called. We'll get back to that. So this is the API. It's a promise that returns an MS assertion. I mean, you've noticed that we're using MS prefix to again denote the fact that these are experimental. There are a bunch of information about this assertion, but I think I want to kind of point out to the key things you need to keep in mind. And the key here is that ID that says the DOM string ID. And And that's important because that's the way you can find your key later. So when you create a key pair, Windows gives you back an identifier that you need to remember and pass it for later use. So it's a very important thing to keep in mind, and we'll get back to it. The rest of the parameters are more or less fixed. For the current implementation, again, as you know, things will change. The second thing that you need to remember from this make credential, the return object has this member called public key. That is a very important thing as encoded in a JSON format, and these are details, but the point here is that once you get the public key, this is what you need to send back to your server. This is the lock that I mentioned, right? You need to make sure your server knows of it because it's a new credential type for that user. And the rest of this, again, are more or less fixed. We can talk about them, but I don't think there's so much that you need to know. And once you basically created this credential, in terms of the key ID, you have two options. You either can pass a key ID to the API through the user ID, or if you don't pass anything, the system generates one for you. But again, it's very important to know that that key ID is something you need to hold on to and don't lose. If you lose that key ID, you have no way to find your key again. There is some parameters here that are meant to be used even in future. For example, one of them is this thing called the authenticators. That is basically an AA GUID. And what that is, in future, once we support multiple devices, a website can decide what kind of devices it supports. Perhaps you want to say, I only allow phones. And so it can pass the AAD GUIDs that belongs to phones, and that is what we use to decide what devices you can use to create your credential. And the last parameter is a challenge, which is optional. In terms of, okay, so now this creates the basically keeper. Actually, I have created a very simple website that we could use to just see the output of these parameters. So let me go ahead and specify my user ID, which is me declaring that I want to declare the key ID for my key. I don't want the system to generate it for me. So let's call it build@outlook.com, why not? And so when I click make credential, see what happens. Again, the face authentication comes up, and then it tries to authenticate me. As it sees me and I click on OK, then it goes ahead and creates the key pair. And it's very important. What Windows is trying to do is that before it can create the key pair for you, it verifies that the user, the owner of the device, is present. And when it does succeed with the call, as you can see here, there are certain parameters we discussed, like the ID. In this case, I pass the ID to the API, so it's exactly the same. And for example, transport head is embedded. That's always the same thing in the current implementation. I'm not sure if you're interested about TPM key attestation, but that is not supported in the current version. It's something that is coming in the later one. And so basically, at the end of this, Windows have created a keeper associated with ID that equals to build@outlook.com. Now that you have that credential created in the system, what can you do with it? Well, the idea, if you remember, was that to prove your identity to the server by proving that you own the private key associated with that keeper. Remember the lock and the key? We want to kind of do that in the API. And the way you do that is the server sends back a challenge. Think of it as something that proves that it's a fresh communication. This is not something that is being replayed. And that challenge has to be cryptographically signed with the private key associated with the public key that the server knows. So the server calls this get assertion, and as part of that, it's very critical to pass an ID for the key that needs to be signed. In the current implementation, that ID is required. In future implementation, it becomes optional. And as to what that means, that's something that the standard is looking at, but for now it's required. And also at the same time, the server can pass a parameter to the browser that can be shown to the user and will be included in the signature that is returned to the server. So the server has guarantees that basically the user saw that string. I'll show an example how this would look, so bear with me. And at the end, the output is an MS assertion again, which has a signature object in it. And that signature itself has basically three member data. One is the client data, which is the UTF encoded of this JSON format, basically a challenge and the string that was passed. And the challenge and the nonce are the same thing. I keep using one terminology for the other. And then the authenticated data is that fixed number. And then, so the signature is basically what it is it takes the authenticated data, concatenate that with the SHA-2 hash of the client data, and then UTF-8 encode the whole thing. And that becomes the signature. So let me just show you real quick about that string prompt that I mentioned. So let me go ahead and send, so on the right-hand side, I'm going to do a get assertion call. So let's pass a challenge. This is a challenge, obviously. I have to pass a credential ID, which I will copy from the one that I created. Remember, I have to remember this when calling the get assertion. So I'm going to go ahead and pass this guy here. And then I also will say, hey, I want to specify a string to be shown to the user. So perhaps we say, welcome build. So when I call get assertion, see what happens. It says, welcome build right here. And my face gets authenticated. And this is basically what happens. The get assertion, before it actually accesses the private key, it makes sure that the user is present. And the way it does that is basically what you just saw. That was my Windows Hello experience within the browser. So in summary, things to kind of remember is when you call the first API, that's where the key pair gets generated on the system. You need to remember the ID that is given back to you. And if you use the same ID for creating, if you specify your own ID, the key will be overwritten. As part of the first API, you need to basically get the public data, public key out of it, and then that it becomes the new kind of credential for the user that the server needs to know of. And as I mentioned, you can either put the ID in the IndexedDB, but we recommend that you actually store it on the server, so if the user deletes their cookies, the keys are not gone. And when it comes to get assertion, you need a challenge or a nonce, and the output is the assertion, the signature that goes to the server, and remember you can specify custom or contextual string as part of that signature. There's no delete API with the new web APIs, and the idea there is that you can always override the keys, and the user can simply go and delete their PIN, and as part of deleting their PIN and Windows Hello, they basically can delete their keys. We don't support TPM key attestation, which basically is a capability for TPM devices to prove to a backend server that the keys are protected by TPM hardware. In the current implementation, it's not supported, but in the upcoming ones, we will add that support. And in terms of key isolation, the current implementation isolates the keys generated in the app from the keys that are generated in the browser. And also within the browser keys, they're also separated based on their origin. So that brings me to the end of my talk. We got technical at the end, but I wanted to kind of bring to your attention the experience you saw today. I just click my name, show my face, and sign in. And these are type of experiences that one could expect once this FIDO and these new APIs get common across platforms. It's going to be a very pleasant experience for authentication because you don't have to remember any more passwords, and you're going to be way more secure than what used to be with password. We are very excited about this framework. We have some really exciting partners that are building POCs and prototypes with this because they also see the future, and we would love for you to also start prototyping and asking questions and feedback. So what I have done here is provide you with a link for a blog post that we plan to update as we get more data. There are also links to W3C submission that you can go and look. And please get in touch with us. If you're interested, We would love to hear your feedback. And thank you so much for your time.